Hello everyone, my name is Chandrakant and I'm a technical consultant at Microsoft. Welcome to my session on foundational concepts of generative AI and LLM. Some of the major topics we'll cover in this session includes concepts behind generative AI, different types of generative AI models and how Gen AI has evolved over a period of time. We'll also understand what are LLMs, how are they related to Gen AI, what are some of the popular LLMs and how LLM models are different from traditional machine learning models. Then we'll deep dive to understand how LLMs read input text and produces human-like answers. As a foundational concepts course, there are no prerequisites other than a keen interest to learn. Let's start. What is generative AI? Gen AI is a subset of artificial intelligence that learns from data it has been trained on and generates new content output such as images, video, music, text, etc. Gen AI produces different contents like images, video, music, text, etc. But how? The answer is Gen AI uses variety of model architectures. Let's discuss about them. Although there are multiple, but we'll limit our discussion to these four major model architectures. So we'll start with variational autoencoders. They're commonly used for tasks like image generation, data compression, and denoising. Then the second one is generative adversarial networks, commonly used for image synthesis, style transfer, and data augmentation. The third one is autoregressive models, commonly used for sequential data processing. And the fourth one is transformers, commonly used for large language models. So now let's move forward and discuss how Gen AI has evolved over a period of time. In 1950s-60s, early AI prototypes were typewritten chatbots, relying on knowledge bases maintained by experts. They are termed as artificial intelligence. Then, in 1990s, a statistical approach applied to text analysis led to the birth of machine learning algorithms, allowing machines to learn patterns from data without explicit programming. Then, in 21st century, advancements in hardware technology, particularly neural networks, significantly improved natural language processing, enabling machines to understand the context of words in sentences, and they're termed as deep learning. And finally, in 2021, a subset of deep learning called generative AI emerged after decades of AI research, enabling machines to generate human-like responses and content autonomously. Let's understand LLM now. LLM stands for Large Language Model. They are the model which are trained on large amount of text data that is capable of understanding human text and or generating human-like text, specifically applied to perform language-related tasks. So the question arises, which type of generative AI model is LLM? And the answer is, it is a type of transformer model, the one which we have seen in our previous slide. Let's have a look on some of the popular LLMs now. So we have almost like four of them. ChatGPT by OpenAI, Gemini by Google, Llama by Meta, Claude by Anthropic. By now, we know that LLMs are trained on massive datasets. But what datasets are they trained on? So they have been trained on news articles, documentation, Wikipedia, scholarly articles, books, research papers, etc. This is not an exhaustive list. There are other datasets as well on which they have been trained upon. Let's understand the working model of LLM and how we interact with them. Prompt. They are input texts provided by users, basically queries. LLM read input text and provides contextual answers or output called completion. In this slide, we'll have visual comparison between machine learning model and LLM model. As we can see, in machine learning model needs to be manually trained using different algorithms and data labels, and then outcome is predicted. They are effective for discriminative tasks like classification, regression, etc. While in LLM models are pre-trained with datasets, an outcome is predicted based on prompts. They are effective for generative tasks like text generation, dialogue, etc. Let's play around with a couple of LLMs. We have two tabs. First, showing Microsoft Bing. Second, showing ChatGPT. In Microsoft Bing, we have entered the prompt, "What is YouTube? Please explain in a few sentences." And the second one, the prompt that we have entered is, "What is India? Please explain in a few sentences." So both of these LLMs, based on the prompt, it is trying to give the answers. I would encourage you to play with ChatGPT in your free time. By now, we have seen LLMs generate output based on prompts, but question is, does LLM look over internet to generate text? The answer is no. It does not search over internet. Instead, it predicts answer based on the dataset that it has been trained upon. In the next slide, we'll deep dive to understand how LLM generates text. But before we start analyzing flow diagram, we must remember that LLM is transformer model with encoder-decoder architecture, and the same encoding decoding technique is being used to generate output text. Let's understand steps involved. Input encoding. The process begins with the input prompt provided by the user. This prompt can be a single sentence, a paragraph, or even longer text. The LLM tokenizes the input prompt into smaller units called tokens. These tokens can be words, subwords, or characters. Each token is then converted into numerical representation, usually called embedding vector, using predefined weights from the model's encoder. The second one, autoregressive decoding. The LLM generates text autoregressively, meaning it predicts one token at a time based on the context, previously generated tokens. The initial context is the encoded representation of the input prompt. For each decoding step, the model takes that context and predicts the next token's probability distribution. The token with the highest probability becomes the next output token. The context is updated by appending the newly generated token, and the process repeats until a stopping condition is met. The third one is the sampling strategy. LLMs can use different sampling strategies during decoding. Greedy sampling, always select the token with the highest probability. Top K sampling, randomly sample from the top K most likely tokens. Temperature-based sampling, adjust the temperature parameter to control randomness. Higher temperature increases randomness. The choice of sampling strategy affects the diversity and quality of generated text. The fourth one, output tokens and probabilities. At each decoding step, the model produces a probability distribution over all possible tokens. The token selection is based on the probabilities, which reflect the model's learned language patterns and context. The model balances between exploiting high probability tokens and exploring less likely ones. And the fifth one is the stopping criteria. Decoding continues until a predefined stopping condition is met. Example, reaching a maximum length or generating an end token. And the final output is the sequence of tokens generated by the model. Some of the LLM terminologies. Prompts. The initial input provided when we interact with an LLM. Completion. Text responses produced by the model based on the given input. Then we have tokens and tokenization. Tokens are the fundamental units of text that LLMs process. And the process of breaking down inputs and output text into these smaller units is tokenization. Embeddings. Embeddings are continuous vector representations of the words or tokens, for example, owned, and the numbers with which it is represented. Just to summarize what we have learned so far, we have touched upon generative AI, different types of AI models, and history of Gen AI, popular LLMs, list of datasets, comparison between ML model and LLM model. Then LLM text generation algorithm and basic LLM terminologies. If you enjoyed this video, don't forget to share this video with your friends and do remember to hit the like button and subscribe to my channel. See you all in my next video. Stay tuned.